first thing we're going to do is we're going to draw a diagram here. Here you can say is our little lamp, and then here's the triangle. Okay, and then we know that this is 20 feet tall here, and then we know that the little girl, give her some hair, is 5 feet tall. And then we're just going to name this distance from the little girl to the lamp, the line over here, as X, and then the line, and then this distance as Y. Okay, now I'm going to switch to a different marker. So another thing we can do now is we can write a proportion. So we know that proportion from 5 to 20, so the height of the girl to the height of the lamp post, and that will equal to Y over X plus Y. So the distance from the shadow to the girl, that to the distance of everything from the shadow to the lamp post. Now we can solve this equation. And what you're going to get is that Y is X over 3. Now you're going to differentiate this now. And you're going to get that dx dt, so it's the rate at which the girl is moving away from the light. This distance is 6 feet per second, and this will equal to dx dt. So you're going to get 1/3 times 6 equals 2. So the rate at which the shadow is lengthening is 2 feet per second.
So in this problem, a tank of water in the shape of a cone is leaking water at a constant rate of 2 cubic feet per hour. The base of the tank has a radius of 5 feet and the height of the tank is 14 feet. There's two things that we need to solve in this problem. A, at what rate is the depth of the water in the tank changing when the depth is 6 feet? And B, at what rate is the radius of the top of the water in the tank changing when the depth of the water is 6 feet? So in this problem, let's start off with a quick sketch. In this picture, you can clearly see that the water in the tank actually forms a smaller cone with the same central angle as the tank itself. The radius of the water cone at any time is given by radius r, and the height of the water cone at any time is given by h. The volume of the water at any time t is given by this equation. And we have been given that the change in volume with respect to time is 2 feet cubed per hour. Except in this problem, h will have to equal -2 because the change is actually decreasing. So in the first part, we're supposed to find the rate at which the depth of the water in the tank is changing when the depth of the water at 6 feet. So for this part, we determine dH dt when h equals 6. And now we actually have a problem because the only equation that we've been given is this one, which is the equation used to find the volume of the tank. However, the only differentiation that can be formulated from this one is which is an issue because in this equation we know what dV dt is and we know what h is because they were actually given to us in the initial problem. However, we need to know what r is, and we need to know what r prime is as well in this problem. But we just don't have enough information to solve for these two variables. So it will be very difficult for us to find these all of r prime as well as h prime simultaneously. So in order to fix this, we will have to eliminate r from this equation so that the differentiation would only be left with h or h prime. So to fix this, let's take a look at the original diagram. It's actually easier than it looks. If we go back to our original diagram and look at just the right half of the tank, we see that we actually have two similar triangles. And remember that two triangles are called similar when they have identical angles, which is the case here. You can see that these angles are identical, these two angles are identical, and so are these two angles. And so, since these two are similar, then the ratio of any two sides must equal. So this would mean that the radius of this equals the radius of the larger cone, and that the height of this would equal the height of the larger cone. So, or in proportion to each other. So, then you would just have r over h equals 5 over 14. And in order to eliminate r from this equation, you would have to set this equal to r. And then you could plug this into this equation. And then you would just have v equals 1/3 pi 5 over 14 h squared times h. And then if you solve this, you would have v equals 25 over 588 pi h cubed. And this gives us a volume formula that only involves the height and the volume. And then at this point, you can just differentiate this equation. So this is the equation that you get after you differentiate, and you can clearly see that we know what dV dt is, we know what h is, and all we need to do is solve for dh dt. So all we need to do is plug these two values in and then solve for dh dt, which we'll do right now. So, it looks like that the rate at which the height is decreasing is 0.1386 feet per hour. And remember, the rate of change would actually be a negative value because the water is dripping out. So the rate of change would have to be negative because the volume is decreasing. So this number makes a lot of sense. Okay, moving on to... In part B, we're supposed to find at what rate is the radius of the top of the water in the tank changing when the depth of water is 6 feet. And this is pretty easy to do because we have the proportion from the previous problem. And this proportion is basically how you would find the radius when the height is at a certain number. And since this problem is asking for the rate that the radius is changing, it's looking for dr dt. So we would have to solve this problem for r, which we did here, and then we will differentiate this with respect to time. And so, we can see that if we take the relationship that relates R and H that we use in the first part and differentiate, we would get a relationship between dr and dH. So then we could just use the results from the first part to get what dr dt is. From the first part, you already know that dH dt is negative 0.1386. So then in this part, we could plug the dH in for this value, and we would just have and then all you need to do is plug this into your calculator, and you would find the rate at which R is changing. This was obviously much easier to do than the first part. However, you were only able to use this easier way because it was asking for dr dt the same time that they were asking for dH dt when h was at 6 feet. If it wasn't the same time, then we couldn't have possibly done this the easier way.